In this video, I'm going to talk about states of matter, and this is probably a review for you, or should be a review, hopefully. So we have three states of matter: solid, liquid, and gas. A solid substance has a definite shape and a definite volume. And the particles are vibrating in place. The particles, which most people, when you look at something solid, you think the parts of it aren't moving, but actually solids do have some motion. I'll explain that a little bit further here in a second. Then we have liquids, which we say have a definite volume, but an indefinite shape. They fit the container that you put them in. So if you put them into a round container, they'll be round. If you put them into a square container, it'll be square. Okay. In this case, the particles of a liquid, they flow past one another. Okay. And then lastly, we have a gas, which has an indefinite shape and an indefinite volume. And this means that it can be easily compressed or expanded. So it's compressible, whereas the other two cannot be easily compressed. And then the particles here are very high energy and not attracted to one another. So the particles are, I guess we say, not attracted. So they're bouncing all around. Okay, so we have solid, liquid, and gas. Now we know, and I'm going to talk further in the next video about phase changes. Phase changes is when you go from one substance to another, but temperature affects whether or not you're a solid, a liquid, or a gas. So in chemistry, we use two different temperature scales. We use Celsius and we use Kelvin, and I'm going to talk a little bit about Kelvin to begin with. Kelvin is known as the absolute temperature scale. Okay, and what this means is that temperature is actually a calculation based on the energy of the particles. So temperature is we say the average kinetic energy of particles. And so kinetic means motion. So basically it's like the average amount of motion of the particles, and its temperature is actually directly proportional to the Kelvin temperature scale. So Kelvin has a temperature in which we have that's called absolute zero. And absolute zero is when particles cease to move. Okay, so the movement of the particles is directly related to the temperature scale, or the Kelvin temperature scale. So we also have, so the Kelvin temperature scale is the absolute temperature scale, and then we have Celsius, which we use frequently. And Celsius is related to the Kelvin temperature scale by Kelvin is equal to Celsius plus 273. So actually absolute zero in Celsius is negative 273 degrees Celsius, so extremely, extremely cold. Let me show you a little simulation just to sort of, demonstrate the Kelvin temperature scale and this idea of motion being equivalent to temperature. Okay, so if we look at this simulation, you see here's the thermometer, and the thermometer has it's in Kelvin, right? So that's what the K means. And so here I have a substance, and it's a solid substance. And you can see how the particles are vibrating in place. They have some motion, right? Now, if I cool it down, okay, even further, as it gets colder, you see the temperature is dropping lower and lower and lower, and the motion gets smaller and smaller and smaller until if I was to reach absolute zero, which I don't know if it'll let me, is when those particles would stop moving altogether. Let's see if it'll go down to zero. There we go. So you see they stop altogether. This is absolute zero. Now, if I heat it up, okay, it's going to then increase the motion of the particles, therefore increasing the temperature. So you see as they move more, the temperature increases. Okay, and if I were to continue to do this, it would eventually melt. But let's look at the difference between a solid. So we see it has a definite shape, definite volume. The particles are vibrating in place. If I make that a liquid, you can see how it has an indefinite shape. And the particles flow past one another. They have a lot more energy because you can see it's warmer. And then if I make it a gas, we can see they're bouncing all around the container, and they're not attracted to one another, and they have an indefinite volume and an indefinite shape. Okay, so hopefully now you understand a little bit better about just states of matter in general and how they relate to the different temperature scales that we use.